Question 8, we've got an explain the meaning of this term. So there were 2 marks available here. One for saying that in semi-conservative replication, we have 1 original strand and 1 new strand in a double helix. And I've termed that very carefully to show what I mean, but I might even use a little diagram, say that's an old strand, and use different colour to say new. In your actual A-levels, these papers get scanned black and white, so if you're trying to do something that you don't normally do different colours, use dotted lines instead of 2 different colours. Okay, second marking point, each strand acts as a template for the new double helix in semi-conservative replication. Next question is a state. We like state questions because we've learnt that we should be able to do it. Just look at the structure of this question. So you've got state 2 other enzymes, so there's going to be a mark for the name of the enzyme and describe their functions. You've got to give me the name and the description. So your first one was DNA helicase, which unzips the DNA molecule, or it breaks those H bonds. Okay, so you might have seen on my marking, I've gone through and I've given you a tick with E number 1 and F number 1. So numbers refer to enzyme number 1 and function of that enzyme. That's your second marking point. And then we've got DNA polymerase. Okay, this is about replication of DNA. Lots of people said RNA polymerase. RNA polymerase is translation. Replication of DNA, we'll look at the DNA polymerase, which forms the phosphodiester bonds. Okay, or joins nucleotides together. Could be another answer there. And again, if I were to go through that, there's your E2 mark and your F2 mark. Okay, so you get a mark for the enzyme, mark for the function, bit of exam technique, read those questions carefully. Okay, this Meselson style question was done reasonably well, but the number one thing I want to say is do use these diagrams. Okay, so they've given you generation 0, generation 1, 2, and 10. So if you work through each of those tubes and tell me something about each one, you will get all of the marks here. If you just use generation 0 and 1, then you won't get the marks. So generation 0, we're saying is in N15. Okay, so relatively heavy. So here we go. We've got 100% at N15. Now, generation number 1, we've had 1 cycle of replication. So what's happened is that DNA strand, the double helix is split apart, and each strand has become the template for a new strand. But those templates are made out of those new strands contain N14 rather than N15. So each molecule is now 50% N14, N15. So the height of this, remember the heavier bands sink lower, so the height has shifted up. And then in our next generation, we get an unwinding of these two. So we keep our 2 N15 strands, and then our N14 strands also become templates. And then we add in a new N14 strand. And what that means is that we get the appearance, these lighter molecules appear up here, whereas these hybrid molecules stay here. And over successive generations, we get a shift up as an increasing proportion becomes molecules made of N14. Now the question is, how are we going to explain this in our answer? So let's read the question very carefully first. The tube labelled generation 0 shows a single band containing bases with only the heavy isotope. Explain how the other generations provide evidence to support semi-conservative replication. So we're going to go through each generation and make a statement for each one. Okay, in generation 1, we've had a shift upwards from generation 0. So that shows that the new band must contain some N14, and we think also contains heavy nitrogen. So moving on to generation 2, the new band contains, up here, N14 only. So that must mean that we've got something there where N14, there's a strand with N14 only that is acting as a template. So you've got 2 more marking points available there. Okay, and then lots of people ignored generation 10, which you could still get full points for that. But generation 10 is important because it shows us that there's an increasing proportion of DNA with that light nitrogen in it. So over successive generations, we increase the proportion of light nitrogen, therefore this must be semi-conservative replication. You didn't need to describe dispersive or conservative replication in this, because the question is saying shows how this supports the hypothesis of semi-conservative replication. So all you had to do is say, this is what semi-conservative replication is, and this is how the hypothesis is supported by this data. Really tricky question. Have a look at what you wrote. I don't think anyone hit all 4 of those marking points. Lots of people hit 2 of them, so that's great. You've still got full marks. But just go back and see what you can add in.